Yesterday, deep learning gave AI the ability to see, to look at millions of images and learn to recognize anything. Today, we give AI an even harder challenge, reading and understanding human language.
And trust me, language is much harder than images for a computer. Seriously, getting a machine to genuinely get the meaning behind our words and sentences, well, that's one of the biggest challenges AI has ever faced. And this whole field has a name: natural language processing, or just NLP for short.
So let's get right into it. Why is language so hard? Well, computers are amazing with numbers, right? Every pixel in a photo is just a number that represents a color. A neural network can handle that easily. But language? Oh, that is a whole other ballgame. It's not just a clean list of words. It's messy. It's built on layers of context, culture, sarcasm, and so much ambiguity.
Take a look at this sentence. I saw the man with the telescope. Seems pretty simple, doesn't it? But think about it. Who actually has the telescope? Am I using it to look at the man, or is the man holding it? Both interpretations are totally correct grammatically. A computer that just follows strict rules would be completely lost here. It doesn't have that real-world common sense that we use in a split second.
Or what about this? If your friend messages you, "Bro, that panipuri was fire," you know exactly what they mean. It was delicious, amazing, but a computer with just a dictionary, it'd be looking for an actual fire. You see? Slang, emojis, all our cultural shortcuts, this stuff makes language incredibly tricky for a machine.
So the first tries at solving this were kind of like building a grammar police bot. Yeah, scientists literally tried to give AI a giant rulebook with every single rule of grammar. But as we just saw, real people break those rules all the time. This whole approach, it was a complete dead end. They needed a totally new idea, a real breakthrough.
And that breakthrough, honestly, it felt like straight up magic. The big idea was, instead of teaching AI grammar rules, what if we could just let it learn the meaning of words all by itself, just from reading? And the secret to doing that? Turning words into math.
This amazing technique is called word embeddings. Now, here's the core concept. Every single word gets converted into a list of numbers, what's called a vector. Think of it like a coordinate in a giant multi-dimensional map of language. And in this map, words with similar meanings like happy and joyful end up right next to each other. But it gets even crazier.
Because what the AI has learned isn't just words, it's learned the relationships between them. We can actually start doing math with concepts. So, for example, let's take the vector for the word king and subtract the vector for man. What are we left with? Kind of the pure essence of royalty or power, right? Okay, hang on. So we have that concept of royalty. Now let's add the vector for woman to it. Just think about what we've done. We took the man out of king, and we've added woman. What do you think the result is going to be? Queen. This right here, this is the magic. The AI was never taught about royalty or gender. No one programmed that in. It learned these abstract relationships all on its own, just by analyzing billions of sentences. It figured out that the relationship between king and man is just like the relationship between queen and woman. That's not just following rules, that is genuine understanding. So this incredible trick of turning words into math, it's not just some cool experiment stuck in a lab. Nope, this superpower is running on your phone right now inside dozens of apps you use every single day. Let me show you what I mean. One of the absolute biggest uses is something called sentiment analysis. This is where an AI reads a chunk of text and instantly figures out the emotion behind it. Is this person happy? Are they angry? Or are they just neutral? And believe me, companies are obsessed with this. For instance, imagine you leave this review after getting a bad Zomato order. Any person can see you're upset. But Zomato gets millions of reviews. There's no way a team of people could ever read all of them. So an NLP model does the work. It instantly reads the text, understands that words like terrible and cold are negative, and flags it. This is how huge companies can find their unhappy customers and fix problems at a massive scale. It's all about understanding language automatically. And it's not just that. You use NLP all day, every day. When you use Google Translate, when you talk to Siri or your Google Assistant, when your keyboard predicts the very next word you're about to type. It's in YouTube's auto captions, Gmail's spam filter. It's even in the fraud detection systems for PhonePay and Google Pay. This technology is literally everywhere.
But for all its incredible power, this version of NLP had a really serious weakness, a hidden flaw that was holding it back from being truly great.
You see, the problem was that these models read language one word at a time, in a sequence. Now, that's okay for short sentences, but for a long paragraph, by the time the AI got to the end, it had basically forgotten what the beginning was about. It would lose the context.
We needed a new way, a new architecture that could see the entire sentence, all at once. Then, in 2017, a single research paper changed everything. Tomorrow, in Episode 6, we meet large language models, the giants behind ChatGPT and Gemini. And I promise you, it will feel like a plot twist. See you then.